So in this video, we'll just quickly look at the key steps that we did for doing the autocorrelation analysis or the time series analysis. So we first take the data set that is in consideration, which is Johnson & Johnson. And the first thing to explore is to do the ACF plots or the PACF plots. ACF is autocorrelation, and the second one is PACF, which is partial autocorrelation. So we first explore that using ACF2, which is a combination. It provides you both plots at the same time, and then you can check as to what is the level of correlation with the previous lags. And this would tell you, for example, the first one, you can see there's a gradual decrease in the values of correlations as the lags increase in previous times. This is t-1, t-2, t-3, and so on. And the partial correlation is the one which shows the correlations, the values which would not be explained by the ACF correlations. And so looking at this, you can decide on the number of lags. So essentially, ACF is telling you how a given value is correlated with the previous lagged values. And as that correlation propagates, you also would like to look at the PACF plot to understand what is not explained by this propagation of correlation from a given value to the previous lags. And so that gives you a rough idea about how many lags to consider. And that basically sets the foundation for your next analysis. And then you can also quickly do an auto ARIMA fit, which for a given set of values, it will let you. So in this case, I'm taking the seasonal as false, and this will allow me to explore the fit. So let's try to look at the fit values. So here you can see AR1, MA1, MA2. So MA1, MA2 are the moving average values. So these are the error terms, and corresponding constants need to be part of the equation. So ARIMA equation would be starting with the AR term, which is the previous lag value, which is 0.42 times t-1, because it is AR1, and then similarly you need to account for MA1 and MA2, which are the error terms and corresponding constant coefficients. So that basically becomes your ARIMA equation, and then you can also set the seasonality. So in this case, we had set the seasonality to false, so it has excluded the seasonality. It has just taken the trend and the previous error terms. But you could also check that with the seasonality effect as well. And so depending on how you have chosen to do the fit. So for instance, we looked at in the previous video, we had done the decomposition function. So we'll just quickly replay that again. So this decomposition is using the additive effect, assuming that the three different compositions, the error terms or the moving averages, the seasonality effect, and the long-term trend, these have an additive effect rather than a multiplicative effect. And that you can again check based on the ETS. And that ETS is again, we looked at how we computed the ETS value. So ETS is the error, trend, and seasonality function. So we had computed this on the log, or you could do the same thing on, you can try this on each function. So you can do it on JJ as the basic data set values, then you can do on the logarithmic values of the same, and then you can do it on using the difference and see what is how it changes, how it makes the data set more or less stationary. So we've directly taken the diff log because we know that this is stationary. We verified that using the Dickey-Fuller test. And so we'll quickly do this HW computation. And when we look at this, you can get this is a Holt-Venter, and you can get the alpha, beta, and gamma parameters respectively. Now in this case, we don't have beta, so the